Okay. Can you hear me?
Yes.
Okay, we can start now.
All right. All right. So let me
Should I
see.
call you in the morning to see what time?
29. Okay.
All right, thank you.
So we'll be looking at OOP,
Okay.
object-oriented
My
programming,
own work tracking.
and basically it's just classes, right? So there are two approach when it comes to programming. The first one is
You want anything?
functional programming.
What's your
So this is basically using functions,
Mhm.
right? So when you have
This, please.
complex line of codes, you just arrange them or group them in functions. Then another way of programming is grouping them in creating an object and then putting those functions in that object, right? We've already seen how to create functions and
The
how
functional programming is just like putting things in block of code, right? Is that what you mean?
it's basically creating functions. So let's say something like this. You can see my screen clearly, right?
You can see, yes.
Okay. So it's basically, let's say we have a function one, right? We define it. We just pass command.
Okay, yeah. I get
Function
you.
function two. So basically, we are just creating functions.
Functions, okay.
We can even try to call function one in function two. So we can even call function one inside function two, and then and so forth, going to function three and the rest.
Mhm.
So basically, we are arranging our code using just functions. Right? That
Okay.
is functional programming.
We can put the
But
next.
object OOP,
Don't try our house too. Not so fancy.
you're using classes.
I
You are
really love
grouping your block
But it
of
was
code, your
there.
complex
Okay,
codes
open it
into
up.
classes.
Oh. Yeah.
Okay, using groups.
Exactly, but classes in this case.
Why?
As so instead of using a function, you still use functions in classes, but all your functions are now grouped. So instead of having
No.
multiple functions like this, I can just have a class that says, let's say a main class, right? That houses all these functions. So this is
Mhm.
basically a class. So this OOP.
Wait, that's my secret.
So it basically groups all your functions.
Mhm.
All right. So let's just go from there. So classes and
Doing it too
objects.
much. Mhm.
Sorry.
Go ahead, I'm listening.
Okay. Okay. So basically, a class is like a blueprint for creating objects, right? Now, everything in Python is an object. What do I mean by that? If we have something like this, if I create, let me,
I will never miss Timmy ever.
if I have a name, if I say name is equals to Adewale, then I want to check the type, print type of name, right?
Mhm.
If I
Mhm.
run this, yeah, let's see what I get. See, I see a class string,
Okay.
right? So basically, this and the back end, like I said, everything in Python is an object, right? And classes is the blueprint, is a blueprint for creating objects. So if we
Okay.
come something like this, class. So every single thing in Python, every single thing you are seeing was created from a class. If only we can see the source code,
Mhm.
okay, great. So we see everything. Do I have my fast API code here? I don't have fast API here with me. Let's see. I want to show you something. Desktop. Let me see if this will have it. It's not showing to me. Anyways, it's fine. So basically, what I'm trying to explain is that everything in Python is an object, and
Mhm.
for you to be able to more like give that object some form of meaning, right? You need to create a class for it. So
Okay.
basically, a class is the blueprint for
Creating an
creating
object.
objects. So let's say, um, so let's create a class called,
An object is an instance of a class. That's a
yes,
good
I'll come to that. Let's get this book. Hold on.
one. Oh, okay. So this instance thing, if I remember, like when you create an instance of a software, right, or of a code,
Mhm.
basically you create a view of that code, and you can open several instances.
Yes, multiple instances of that same class.
Mhm. So it's a mode.
I want to use what can I use? So I want to create a class. Uh give me 2 minutes. I'm coming.
Mhm. Let me go out again.
I'm still with you. Sorry, it's raining here, so I had to sort some things. Can you still hear me? Hello, can you
Yeah,
confirm?
I can hear you.
Okay. Sorry about that.
No problem.
Tomorrow we're good. Tomorrow we're seeing fireworks. Mommy, tomorrow we're seeing fireworks.
All right, I'm back.
Me?
Okay. So basically, what I was saying is that, okay, I've explained that a class is a blueprint for creating objects, right? So
Yeah.
basically, in OOP, right, you are using a class to represent real world things, like real life things and real life situations. For our example here, we are creating a class dog. Let me comment this. Oh, I think I can use this. We are creating a class called dog, right? Now, we know that if we have a dog, right, we want to give the dog a name, like the dog will have a name. This dog will have a name. Let's say we have a dog. We have a dog.
Or you mean like we want to create a class animal?
Uh, okay, we can do that. All
No,
right,
let's
let's
do
let's
this first. No, let's do this first.
all right,
So
all right,
create
all right.
different dogs. You can have dog one, dog two, dog three, right?
Exactly. That's right, yeah, yeah. So a dog, the dog will have a name, will have
Mhm.
an age, like the age of the dog. Now, we also want this dog to be able to do basic things like,
Well, but that doesn't help with the situation.
so we want to like give the command to be able to sit, dog commands to sit, to roll, and to back.
Oh, I need all this space for myself.
All right. So we have a class, dog.
Mhm.
We're trying to model a class called dog. And for every instance of this dog we create, that dog must have a name and age as its attributes. That's
Oh,
one. Next is the dog should also have a particular behavior, right? For example, as human beings that we are, when they see you, your name, your age are basically attributes. Then you also have another side of you, your behaviors. When you're angry,
okay.
when you're sad. So it's a
So an
different,
object, so an object has two things, right? They have attributes that describe them.
and then their behaviors.
I finally wow.
Okay.
Again, a class, or since it's a blueprint for creating an object, it basically encompasses everything that has to do with that object, right? So if that object, for example, if
Okay.
humans, if that human is going to be
Either whether it's an object or a group of objects or a
yes.
class of objects,
So
they
exactly,
have attributes that describe them, and then they also have behaviors that they exhibit as a group.
exactly. Now, since we have this, so we create our class called dog, which what we've done here. From here now, what we did was we create a class called dog, and for now we just pass. I think we still okay, we'll still come down to other things. And then we do this. We are creating an instance of this dog. An instance of this dog. So we use the class keyword. You write the name of the class. Then this should have come up. Well, we'll come to that. For now, we are passing. Then this is basically creating an instance of this
class dog, and then you just pass.
For now. Okay. So basically, what I'm showing you now is how to create a class and how to create an instance of that. How to create a class, right? With this object. So we want to create a blueprint for this object using this class, right? So this is basically us creating a new object, basically. And then this is us creating an instance of this object. So like you mentioned earlier, this can be dog 1. Then we can have another dog 2, and so on and so forth. I'm still going to explain this. So this notes for now. I'll bring this down. We still need this. All right, instance variables and methods. Instance.
You say dog 1 equals what? How do you call the class? So
You just call this class and then put parentheses.
Just like you are calling a function.
Exactly.
Okay.
All right. So we have the instance variables and methods. Now, the instance variables are specific to each object. The instance methods are functions defined inside the class that operate on the instance. Now, what do you mean by that?
Instance variables are what?
Yes, are specific to each object. The instance methods are functions defined inside a class that operates on the instance. So basically, whenever you create a function inside a class, you're basically creating a method.
Yeah. Whenever you create instance method are functions defined inside a class
that
operate on the instance. So basically, if I put a method inside a class and I call that method inside the instance of that class, then that becomes instance method. Is that what you're saying?
Yes. Let's not go far. Let's not go far. Let's do this.
It's a method of a class.
Now, if I want to print the type of fruits, now look at this now. If I print the type of fruits, right? I created a list called fruits with just 2 items. Then I'm trying to figure out what type this fruit is. So what do we see here?
Is it class list?
So why is it showing string?
No, it's showing list. You are looking at the previous one.
Oh, I'm confused.
Just CLH.
All right. Yeah. So now look at this. Now we have a class called list, right? Yeah. Now in this list class, so basically in the back end, we have something like this: class list.
Yeah.
You're following, right? Good.
I'm with you.
Now, let's pass for now. We'll come back to this. Now, we have methods, list methods, right? So we have fruits dot append.
Yeah.
you will not add the what you want to append. So let's say you want to add the
Just add
orange.
D. Okay.
Right? Now, somewhere in this class of list, there is a function called append.
Oh.
So basically,
See,
when you say fruits dot append, you are calling this method. So this basically, right, is like an instance of this list class.
yeah.
These fruits, right? That is one to note. Then when you now call any method, those methods are basically functions defined inside this list class. Hold on, let's do something. List in Python source code.
Or maybe you do list library or something. Maybe you can find it. I've
Okay.
always wanted to see the source code.
Lists.
List source code. List source code in Python.
Just to see.
Or just the library. And then you can find, maybe you can find a reference to the source code. Okay.
Mm-hmm. Okay, good. Okay, I like this. So this is in C, right? So we might have a little bit of yeah, but there is something that I want us to see now. Look at now the file path. So we have this is a link. Okay, good, good. This is a link. This is it actually.
Oh, that's the how they
Yeah,
created the list
yeah,
class.
yes.
Yeah, this is interesting. I've always wanted to see this. So they call class list. Oh wow.
Looking
And
for
then they just
something.
pack all the method in there.
Yes, I'm trying to. No, this is C.
Huh? Yeah, we can still figure it out. It's not too
Yeah,
far
basically,
out.
all these are basically important things. Trying to look for one function that I'm familiar with.
No, look, I want to see where they define the class list and they call it list. That's what I'm looking. See, so they imported everything they want. Okay, and then static dot int.
List tree allocate.
Is dot.
Where is this
But then
coming from?
they are calling that list again.
Yeah, but should be coming from
This
somewhere
is
like
int.
file,
No, no. I just look. Is that list object?
file list object, but it looks like it's coming from somewhere. Let's see. Let's see their imports. File call
Yeah.
list. It's
Python dot.
coming from some. So the
Yeah,
list is
yeah. So if
somewhere.
you can
They
find,
imported it
yeah,
somewhere else. Yeah.
yeah,
They
yeah. They
imported it
imported
somewhere
it
else.
somewhere.
Okay. Now.
But if you check ChatGPT, right?
Yeah, you should be able to find it.
It creates a list object, like main imposition of Python list object. There is a list object. Let's see.
Uh,
But look at my main focus now. The common functions in list object.c. The first one we have PyList new, right? Creates a new list. PyList append.
This
Appends
C
item.
language.
Yeah, this is C.
Okay, but that same concept, yeah.
Yeah. So this is basically what I wanted to show you.
Okay, and then dot append,
Yeah.
print. Ah, but print, they use print in C too.
No,
Or
so
maybe
this
it's Python.
this is in Python. This is in Python.
Okay, Python, equivalent in Python. Okay.
Yeah. Anyways, back to this. Yeah, so back to the function the class we are trying to work on. So we have a function, we have a class, sorry. I don't know why I arranged this thing like this. I should have brought all this up. Should have brought all this up. Well, basically, let me just start with this. Let's not go for. Let me just start with this. So what we have here is our class called dog, right? Now, when we have our dog, we do def init. What this init means is basically initializing. Let me see the okay, initializing the object of this class or instances of this class of this object instead. So I'm missing the word class and object, but I want to believe you know the drill.
Object is a member of a class,
Yes.
an instance of a class. Okay. So yeah, that constructor always confused me. I want to be able to explain it in a layman's language.
Okay. So let's do it this way. So this init method, remember I said every function inside a class is a method. That's one thing to know.
Okay.
Every function inside a class is a method. So all these functions in this class, they are called methods. That's why you hear things like list method, dictionary method. Those methods are actually functions inside the dictionary class. All right. Now, this init method, right, is a special method in Python that automatically runs whenever you call or you create a new instance of this dog class. So basically, if I want to
And you
create,
said
if I want to create, yes, if I want to create an instance of this dog class like dog1, right, and I put dog, right?
I said walk around. It's not around. Around the track, around the track. Okay?
If I come and say dog one dot pick,
Still trying to share.
let's see what happens. We'll likely see an error.
How, right?
We'll see an error, right? Now, the reason I pointed this out is that whenever you create a new instance of this dog class, right? What this init method do is that it gives you, for example, I want a situation where whenever I create an instance of the dog class, right? I want the name to accompany
On the
dog.
brown bag. I don't see it.
Hello, are you still there?
I'm with you.
Okay, so let's say I go to how do I do this now? Self name. Okay, let's do it this way. Let's comment this out. I go to supermarket. I have a class, supermarket, right? Supermarket, okay. Now, I create my first init method to initialize all the new instances of my supermarket object.
I have a function inside function.
I don't need to put this. Oh, sorry. All right. So in here, I want to show you whenever I go to a supermarket to buy a product, right? I have to know the name of that product and the price. Very important. So the name of the product and the price of the product. Two things very important. Then I have another thing in Python. You send in the self keyword. So basically, this self keyword is referencing whatever instance you create. We'll come to that, but I'll just explain something here. So I do self dot name is equals to name, self dot price is equals to price. Then I can create a function that says, okay, what does the product do? Or okay, or in the supermarket we have staffs, right? I can say print two staffs, right? And so on and so forth. But our focus is on this part now. Now, if I create an instance of this class, let's say supermarket super one, and then super market. Now, mind you, I made a mistake here. When you're creating a class, the first letter should always be capital letter. Very important.
Why?
That is a should I put it like
Standard,
a
just standard. It
standard?
doesn't. It's not going to ask a problem, but it's just for.
Exactly, but it's a standard. It's a standard. So the class, the first letter should be capitalized. That's one. Now, when we come in here, right, the moment I create an instance of this class called supermarket, and remember that in my class, I initialized it, meaning whenever I create an instance of this class, I have to also include these two in it. So basically, I'll now come here now and give it a name, sanitary, and then the price, 100.
Okay, I think
So
I'm getting this now.
I can come here now. Let's say, give it a data type. Come here and give it int. So basically, I'm saying this class is a string, and this is int.
But let me ask you a question. We're using semicolon there now. Is it possible for me to use equal to? No, but that's not a value.
Where?
Is it? Okay. This name string is confusing because you use semicolon. So I was thinking if it's a keyword argument, right, that you use equal to, is that not working?
So this is not actually a keyword. So the reason I did this was because look at this now.
I see that a lot, and I want to understand what's that and what's the rule behind it.
So basically, just watch this now, right? When I hover around this name, they tell you that this name is a string data type, right? When I hover around price, it tells you is an integer data type. If I remove this, And I hover around this. You just say parameter name any data type.
Oh, so that's how you define the data
So,
type for the
exactly. So
parameter.
basically, I'm saying I want this data type to be a string.
Mhm.
So instead of price now is currently any, but I don't want it to be any data type. I want it to be an integer.
Mhm. I feel it.
So now if I come here, it has changed to integer, no longer any.
Okay.
The idea is that if I come here now,
And you
right?
try to
I'll
enter
string.
something, anything, it will come to error.
Exactly. Exactly. Anyways, so back to what I was saying. Now, two
Now,
things now.
now it's making sense to me.
All right. So two things. The moment I create this instance super one of this supermarket class, right? Of this
Mhm.
object.
Mhm.
Remember, I initialized it with the name and price. Now, mind you, this self keyword is referencing this.
Okay.
This self keyword is referencing this. So if I create
Okay.
another super two is referencing this self.
Okay.
So it's basically you saying just copying this and bringing it here, basically. All right.
Mm.
Now, these are instance variables. Instance variables. And like I said, they are specific. If you come here and I will say that word, they are specific to each object. We meaning
Okay.
whenever you create an object, whenever you create a new
Object
instance,
is the instance.
yes, no. Object is
Object
not
is
the
the class.
yes. Whenever you create
Eh?
an instance of that object, of this supermarket object,
Oh, okay. Class itself is an object, correct?
yes, yeah. Class is the blueprint for an
For the
object.
object.
Yes.
Okay.
Everything happening here is basically a class.
Okay.
All
But
these are
the
basically, but this is the
okay.
object. This is object. So we are creating a blueprint for this object. Now, this is an instance of that blueprint. So it's like you are doing a house plan, right? You want to build multiple houses with one house plan. But
Mhm.
for some houses, you want to have maybe the kitchen in one side. You don't want the kitchen to be, let's do this way. Do I have my this open? Let's see. I think this should work for us now.
So supermarket is the object. Class is
Yes.
the blueprint for printing the object.
Okay.
So an instance of the object, an instance of the class. So what is that? What is an instance of a class? It's just an
Yeah.
object. It's an object, right?
I won't call it an object. It's an inst. Why is it like this? Hold on. Let me show you. Let me just show you an example.
Not last time. This is kind of dark. But
Okay. All right. Now, let's assume this is our supermarket class, right? We have this class or we have this object. Now, I want to create an instance of this object. Instance one, instance two, instance one, instance two. So we have two instances. You are following me, right? Okay. So this is the object. These are instances of this object, right? Now I'm saying the moment I create an instance of this object, right, it automatically have everything that has to do with this. It's automatically with this. It's basically like having duplicates.
You do. This is kind of confusing a little bit. Can you start over?
Okay. Let me
No, I see. Oh, you see.
all right. This is an object, right? Then we have two instances of this object. Now I'm saying once you create an object, mind you, I say that a class is like a blueprint for an object, right? Now we've created an instance one of this object. Basically, once you create an instance, every single attribute of that object, it automatically takes it. But now I can decide to say, now for instance one, even though I'm still getting all these attributes, I don't want my 2 to be here. I want my 2 to be here. And then I want my 4 to be here. Then for instance 2, I want my 1 to be here. And I want my 4 to be here. Mind you, all this we are still taking from this object, right? But there are different instances. I don't know if you're following what I'm saying.
I'm with you. I'm just I'm moved because of kids' noise.
Okay. So all these two are instances of this object, right? So we just got a blueprint. Remember, the class is like a blueprint for the object. All we are having is just the blueprint. And then once we get that blueprint, we can decide to do whatever we want to that blueprint whenever we get a new instance of that object. So I have a blueprint of my class, which is the object. Then when I create an instance of that object, I can decide that for this blueprint, I don't want 1 to be here, or I don't want 2 to be here, I want 4 to be here. But all the same, it is still got this instance was still gotten from this original blueprint. That's what I'm saying. So when I come here, super 1 is an instance of this object. Super 2 is an instance of this object. Mind you, the class doesn't really do the class doesn't, it's just a blueprint. For example, it just tells you name, price. You will come in here and put
And
in the
define
name.
it.
Exactly. It's just a blueprint, basically. Just a blueprint. Everything that's happening, you are the one that is
So
working
super
on.
one is an object then
It's an instance of
of
this
the supermarket objects.
object. Exactly.
Okay.
Exactly.
It's a photocopy. No, it's not a photocopy. It's an example of supermarket. So you can think
It's,
about it like that.
yeah,
What
it's
is
just
it?
like mm,
Trying to
yeah.
find a simplistic way to explain this to a child. So if I say my supermarket is an object and I have an instance of that object, right?
Okay.
I have is, like when you have dog, you can have white dog, blue dog,
Yes. Yellow
red
dog.
dog.
Yeah.
So I have different type. So we can call it type of an object
Mm,
or species or varieties or items. No. Number of you can have several supermarkets. I think that's big. You have several dogs. Makes sense? Does it make sense?
That makes sense.
Dog is an object, but I can have several dogs, which means I can have several supermarkets. So I have a blueprint to print supermarket, which is the object. Now I can print supermarket 1, supermarket 2, supermarket 3, supermarket 4, like that. So I can just say is not types, it's just number of it's just the number of supermarket that you created out of your blueprints. Supermarket created out of your blueprints. Something like that. It's so hard to explain to find the right word for it, but I get it. I understand it. So have an object, we can have different type of an object. It's just like having a mode. So I can think of supermarket as a mode for making supermarket. And then I can create, let's say it's a candle. Let's call that supermarket instead of supermarket, it's called candle. So it's a mode for making candle. And I can mode as many candles as I want using the same mode or mode for making blocks. Then I can make like a block making machine, right? They have a mode in there. So that mode is the object. And now I can create several instances of that object.
Okay. Yeah. That makes sense.
Yeah,
Yeah,
I
go
think
on.
I think that might be it. So we can think of the object as a mode in a layman's language. And then I'm using it to mode several copies of whatever of what I want, of the object I want. And then when I'm making that copy of that object, I can decide that, okay, this mode, instead of the color to be green, I can make it red. I can make this one. So let's say my mode come with the self, and I say material type, brick or cement. I say color, red or ash or gray, right? And then when I'm making that, and I can say mode, and I can change that parameter in my the one I'm creating, and say you are going to be brick, and then you are going to be red, and then you are going to be cement, and you're going to be gray, something like that. Okay.
But the main point is that we have a blueprint.
Hey, look. Now.
Right? For example, like the let's use the example you gave, right? We have very good. Our block molding that block molding machine, right? It has a blueprint of how the block should be molded.
Yeah.
Exactly. So we can have different designs or different styles of block molds.
Yeah.
Right? But for one machine, so that machine is like the blueprint. Now, for every block mold we are getting, that's like the object of that block.
Mm-hmm. And every block must come, you must add cement.
Exactly.
Before you can create, so there has to be
all
cement.
All those are not the behavior attributes
that come with every instance.
Exactly.
Okay.
But all those things are from the initial blueprint.
So every time you turn on that machine, you want to make a block.
Exactly.
It comes with that attribute already.
Exactly. That's I think that's the perfect illustration. Exactly.
Okay.
So that's what's happening here. So we just initialize this function is to initialize. So whenever I just call this class, right? I have to call also the name and the price.
But I can just say self, right? Without attribute as well.
Yes. If you don't want any attributes, can just say self. That's good. Yeah, why not?
Okay.
Well, anyways. So back to this. I think we've already gone far. All right, so remember I said the self refers to the current instance of the class. I explained that.
Mhm.
It is required as the first parameter of all instance method, which means whenever I'm creating a method in my class, right, I have to also pass that function. So let's do this now. So we have a dog class. And then we initialize our class. We say self name as a variable. I can just put it as string if I want to. I don't have to, but I'm just putting it to define it. Now, I'm saying that for the behavior, this is like attributes. Then the behavior is that I want the dog to be able to speak, right? And I said you have to pass self. Whenever you create a new function inside this class, you have to pass the word this self keyword, because like I
Okay.
said, this echo is referencing this.
Okay. So that self is helping you to say, hey, this method applies to every instance that is
It's
created.
simple. Exactly.
Okay.
Exactly.
Okay, now show me. Start again and then show me. I see some invisible rock.
Okay, let's go.
Oops. You don't use that. Show me your bet. But you're not doing your bet. Easy to learn.
All right.
Watch me. No, watch me.
Okay, I'm with you.
Okay.
You need
So
to do that.
now I've created an instance of this class, right? Called dog1. I have to pass a name. So let's give it a name.
Mhm.
Roscoe. So if I come here and say dog1 dot
But,
name, or let me just print
oh, okay. Then it's going to print Roscoe.
exactly.
So you use dot notation to bring out the attributes too?
Yes,
Okay. Not just method.
not just method. Why is
No, he said it do CLS so you can see it.
I think that,
He did it
this is also
because there
printing
are
that.
some. Yeah, he
Yes,
was bringing that.
if I run
Interesting.
this uh something
It's not working.
See that?
line
100.
124. We have other code that are still running.
Yeah.
Well,
Okay, I'm done.
right now the good guys are
So if I
doing.
run this, I see Roscoe,
They're just collecting on
Roscoe,
the magnets.
and then that is for the first one.
Yeah.
You
And then when I want to call the method, right, all I have to do is to say dog1 dot speak, then put this. So once I run this, it's going to print out Roscoe says woof, which is what it say here.
I just didn't.
I hope that's clear.
Yeah. So basically, you want to call the attribute from the main, from the self. You use dot notation. You use the instance
Mhm.
name dot notation. Or if you want to use Okay, so there are class attribute and then there should be method at level 2. So let's say
Yes,
speak now,
obviously.
for
So
example.
yeah, I can put
Yeah, that's what I'm
this
thinking.
again. Yeah, it's remember I said this is a function. You can have
Mhm.
parameters in your functions.
Okay, so when you
You
want
can
to call that,
you
then
you,
you
you
call
still have
it, you will first
you
of all call the class name and then call, I mean the instance name, then dot the method, correct?
yes.
Then dot the attribute.
Mm-hmm.
Okay, okay, okay. Yeah, it's fun. It's actually very fun.
Okay.
Okay. So yeah, I'm feeling you now. So class dog,
Yes.
init method is initialization. Basically, just to define to say that this class or this blueprint will always come with this. And for it to know that every instance they come with it, will always come with this. And then we'll apply to everything that has self. For example, if I define a function here now and I don't put self, it was going to give me error, correct? Yes, leave you.
No, I'm here. Yes. That's what I want to actually try now to show you without self.
Okay. It should give error. Oh, it's already okay. This one saying remove that dot name. Just or comment the just put it as a string. Put it as a string or something.
It would even work because when we put self.name, right? It
There's
was
no self.
referencing this.
Oh, it's referencing the boss.
Yes, the initial, uh, our initial,
Mhm.
when we put self here,
Yeah, yeah.
right?
Now it's going to
Reference
reference that.
this. So if I
But
remove this,
because of global scope,
unless I just put name here, if I put name here, then it works.
yeah, that works. But my point is even that the reason why this self thing is not working is that if you put self inside that code block, right, in the execution, right,
Yes.
the problem is that it cannot see the class, it sees the class self, but why is it not recognizing? Is it because of scope? Is it a scope problem issue? I'm trying to think.
When for
Okay, like Control CC again. Yeah. Okay, leave it at that. Leave it at that. Nothing there. So now this self, I was thinking, you see, it's blue now because it's thinking is the main one, right? It's trying to reference the global, the first one that was mentioned. But there is a local scope in the niche method, and then there is also a local scope in speak method. So how was he even able to reference this? That's my point.
able to reference this self,
You see now, like if if you remove the self in the init method, right?
yes.
That should turn to white. Oh, it didn't
Uh-huh.
change. Okay, okay, it did not change. Don't worry. It wasn't referencing it. It
Okay.
wasn't. So I was thinking the self inside the speak. I was thinking it's automatically referencing the self inside the init method. But at the same time, I'm thinking like that shouldn't be the case because uh there is local scope for init method and the speak at the same time. They shouldn't be able to see each other's stuff. And I think that's what is happening, right?
Uh, I won't really say that. So let's try something. Let's do this. So I've created my instance or
Mhm,
my object dog1, dog.
mhm,
I've given it a name, row
mhm,
school, right?
mhm,
If I come and I say print dog
mhm,
one dot name.
Mm.
I'm going to get Roscoe,
Yeah,
right?
yeah.
Let's see now. Dog one dot speak.
Speak. It's not gonna print. You didn't put print.
There's print in the function already.
Oh, okay. Ah, okay, okay, I see.
See? It
It's
just
giving
says this person says wolf.
it's only saying the first one. It doesn't talk
Exactly.
about the
So, yes, because
wait. I'm
let's put
confused.
wait, hold on, let's put a name here.
Okay. Put JJ or something. No,
Now,
no,
now,
no.
now it's going to work. It's not even still working. Take but two we are giving. See? Dog one dot speak.
Is it working? I didn't see it.
It's not working actually.
It's not supposed to work. Give it a different name. That's when you know, yeah, it's not supposed to work because there's no self. Or is
Exactly.
it?
No,
Yeah, this.
is that self because when we didn't put this,
I think this will only make sense if I define a function within the class and I call the function within the class. Then I can do what we did now. Would that make sense?
come again.
You see, as that function doesn't have self, right? It should be possible to do that. But that function, you cannot call it outside of in any instance. You can't call it in any instance, but you can
Because
use it to process another function within the class.
yes, exactly. So I can use this function,
Inside
right?
that
Like
class.
this,
Yeah.
without self, inside
Yeah.
this class that have maybe a self keyword.
Yeah. They
Is
create
that
another one, say a
yes?
dance or something.
But I
Yeah.
can reference this.
And
But
then you can reference that and call it in itself. Yeah.
that function should not have a self keyword.
Yeah. It doesn't
But
need
like
to have a source keyword. But if you have to use it inside the instance, then you must have self.
have a self, exactly.
I get it.
So that is basically it. Exactly. So just look at this now. We have a student class,
Mhm.
right? We initialized it, self, name, age. Then you come here, self.name is equals to age, self.age is equals to age, right? Now look at this greet method now. All the past thing was self.
Mhm.
Then they were not basically
Name.
calling name and
Calling
age, the
the
attribute,
class
yes,
attribute, right?
attributes. So whenever you do student dot or s1 dot greet,
Wow.
you're just going to get hi, I'm Alice and I'm 14 years old.
Yeah, yeah, yeah. Okay. Because it's using class attributes. But if you
Yes.
use the method attribute, assuming that method has its own attribute, then you can also call the function inside, call the method inside the instance, and then reference the attribute that is, I mean, the parameter that is associated with that method, right?
Yeah. Yeah.
Okay. Okay.
That's right. That's right. So I
Okay.
don't know. I think we should end here for now. Don't want to
Yeah,
crowd
yeah,
because
yeah.
the next
It's
is
fun.
inheritance and polymorphism.
Polymorphism. Well, and okay, don't worry, I'll find some exercise on ChatGPT. Now
It's not even just
I want to practice now
all right,
bef-
all right.
before the kids will come. Once they come, sorry. Mm. But
It's
this
fine.
is
Just
fun.
just play around this.
Now, yeah, now I'm getting it's making sense. You know,
Yeah.
like I used to think, what is this innate method? Yeah. What is
Uh,
self? Why are they not? Why some will have no self, some will have self.
self.
Then you will see they were not using the parameter inside the function they were using. Never understand why. But it's okay. I think I think that guy just jumped into these things. He didn't explain it to anybody. We're just doing it. And it was the wrong way to introduce to Python.
But it's all good.
Yeah,
So-
so I can imagine a lot of people will have given up. They are not doing this anymore. So, but I don't give up. Okay.
All right. So we'll see tomorrow on Saturday.
Okay. Thank
On
you so
Saturday.
much, and sleep well. Hope you don't.
Thank
Hope you don't. You're not late to work tomorrow.
Nah, I'm fine. I'll be fine.
Okay. Thank you so much.
Thank you. Thank you.
Yeah. Bye
Tomorrow
bye.
on Saturday.
Okay.
Yeah.
Sounds good. Yeah. Thank you.